Can you view the PPT?
Yes, ma'am.
Yes.
So welcome you all in the virtual mode in DDUC College, and you already know that this is the scenario of pandemic, and that's why you are not being able to attend the classes physically in the college, and that's why all the classes are going on in the online mode. And I hope this is your first class, or already some of your classes have already been started.
No, ma'am, this is
Okay. Now, this is your computer system architecture paper, which will be taught by me, myself, Dr. Anuja Soni. And another computer science core paper is your C++ programming, that will be taught by Dr. Rajan. And soon he would also start taking your class. Already you have spent so much time in attending the orientation programs, though earlier the session was started from 18th of November. So this is the time to now to attend your classes sincerely from the very first day, because your mode remains your semester mode, and hardly 2.5 months are devoted to your semester. Once your session is started, immediately after 2-3 months, you will realize that your process of exams is started. Initially the practical exams will start, and afterwards your theory exams suddenly will start, and you will be left with no time. So that is why I would advise you to be sincere from the very first day. Attend all the lectures sincerely, and whatever the concepts we are doing in the class, you have to revise all the concepts at your home, and based on those concepts, because this is the logical and numerical based paper, and based on the contents taught in the class, you have to solve the back exercise that will be given as a part of your assignment. Now we start from the very inception. This is your computer system architecture paper. This is a core computer science paper. Here we'll be studying the internal architectural details of your computer system that specifically belongs to the central processing unit. And if you talk about your reference book, this is your the title of the book is Computer System Architecture by M. Morris Mano, and specifically your third edition is prescribed in your course, and the publisher is PHI publisher, as well as the same book is also published by Pearson Education. Only the page numbers are different, otherwise entirely the contents are same. This is my mail ID. If you would like to send any kind of the mail regarding some of the information, you can send me to my mail ID. Now, if we talk about the breakup of your marks, you do have two components in your theory paper. 75 marks are assigned to your theory exam, whereas the 25 marks are assigned to your internal assessment. Internal assessment will be based on three components. 10 marks are assigned to your test part, 10 marks to your assignment. It may be a single assignment, or it may be a number of assignments, and the 5 marks are assigned to your attendance. You have to remember that in order to appear in your final exam, there is the minimum constraint of 75% of attendance.
Ma'am,
Yes,
PPT
yes,
is
please.
not visible.
You are not being able to view the PPT?
Yes, ma'am.
No, ma'am.
Only you or all of you?
Ma'am, all of
No,
us.
ma'am, PPT is not available.
PPT not visible.
Yes, ma'am.
PPT is, let me share it again then. Let me share it.
Okay, ma'am.
Now the PPT is visible to you?
Yes.
Yes, ma'am.
No, ma'am.
Okay. Now we are at the very first slide of the PPT. The title of your paper is Computer System Architecture, and so far as the book is concerned, you have to follow this book, Computer System Architecture by Please, all are requested to mute your mics.
Excuse me,
In
ma'am.
order,
Ma'am,
or
PPT is not visible.
PPT,
Yes, ma'am.
nobody is being able to view the PPT.
No, ma'am, I
No,
can see
ma'am.
it. No,
Ma'am,
ma'am.
I can see.
PPT is visible.
Pin, pin down.
It is visible, ma'am. I cannot see, ma'am.
Hello.
First of all,
If you are not able to see the PPT, kindly leave the meet and again join it. Maybe you will be
or
able.
otherwise, you pin down to your speaker. You will be able to view the PPT. Just try with it and let me know.
Yes, ma'am, now I can see.
Now you can see now. And what
Yes,
about
ma'am.
others? Now mute your mics, please. Now I'm going to start. So this is your title of your paper, Computer System Architecture. And if you talk about the book, this is your reference book that you have to follow from exam point of view, Computer System Architecture. The ebook of this ebook is also available, but side by side you have to buy the hard copy of the book as well, because it is not always comfortable to go through the contents from the e-copy of the book. Though I already have sent you the e-copy of the book. Now, if we talk about the breakup of marks, your theory paper uh, is basically divided in two parts. The marks of the theory paper is divided in two parts. 75 marks are assigned to your final exam, final theory exam, whereas the 25 marks will be given by the respective teacher of your respective subject. And the internal assessment marks consist of three components. 10 marks are assigned to your test, and 10 marks are assigned to your assignments, and the remaining 5 marks are assigned to your attendance. If you feel some kind of the problem, you can interrupt me, either the audio problem or some kind of the visibility problem. And 5 marks are assigned to your attendance. I would like to repeat that in order to appear in your exams, minimum 75% of attendance should be there. So be sincere in attending all your lectures. Otherwise, you may be debarred from the exams, provided you don't have your minimum attendance. Now, these are your guidelines, or you can call it as your course contents. Detailed course contents are available on your due website and for this paper, and as well as for other papers also. For this paper specifically, these are the guidelines. Guidelines basically consist of a number of chapters and the corresponding section numbers that you have to follow in order to complete that course. And from these, in order to appear for the exam, you have to be confined to the contents of these guidelines only. Means if you talk about first chapter, so as many as sections are visible here, mentioned here in the guidelines, only those many sections you have to refer to in order to prepare for the exams. Similarly, we talk about chapter 2, that is your digital components. Again, various sections are mentioned. So this way, the chapter by chapter and section by section, your guidelines are detailed. And it happens so for all the papers. It's not only for one paper. Whenever the classes will start, all the teachers will provide you these guidelines of their respective paper. You do have 7 chapters in your course. In this class, we'll start from very first chapter, that is your digital logic circuits. Prior to that, I would like to begin with the introductory part of your computers. What is the definition of a computer? Computer is I think most of you already have taken the computer science as one of your core paper in your 12th, one of your elective paper in your 12th. And you would have been a basic idea of your computer. Still, we'll start from the very inception with the definition of a computer. Computer is an electronic machine that can be programmed to accept data, that is called as your input, and process it into useful information, which is called as your output data. And data is put in secondary memory for safekeeping or later use. Computer is basically an electronics device that works on stored program concept, and the data is processed digitally in terms of zeros and ones. And whenever we are going to talk about the processing of data with the computer, some of the data is being inputted with the help of the input devices, which is being processed by the computer, and eventually the data some of the useful information is produced to the user, that is called as your output data. Similarly, whenever data is being processed, data is stored temporarily or permanently in some of the storage device which is called as your main memory or secondary memory. All these are your essential components of your computer. You do have central processing unit, CPU, which is called as CPU. This is called as the brain of the computer. Means whichever the kind of the processing is being done, which entirely will be done by the CPU only. Initially, it refers to the input devices. Initially, with the help of the input devices, some of the data will be inputted by the users. That data again will go to the processing unit, but through the RAM, through the main memory. In order to process the data, always RAM is being utilized. Always the main memory is being utilized. Essentially, there are the two parts of the memory. One is your main memory, another is your secondary memory. Sorry, main memory is called as a volatile memory, but the secondary memory is called as a permanent memory. Volatile memory is there where, so far as the power is there, the data will be resided there. As and when the power will go, the data will be deleted. Once you give a save command, as you do in MS Word, as and when you create a file, you write down some of the data. As and when you click on save button, so data is being stored, or that file is being stored permanently in the hard disk. Hard disk means now that is called as a permanent memory. Once the data goes to the hard disk or any other storage, secondary storage device, in that case, even if the power goes, but next day you can reopen your data. So data is not lost. But in case of your main memory, data is lost until or unless you don't save it permanently to some of the secondary storage device. But main memory is essential to get some of the data processed by the CPU. Without the main memory, the CPU cannot work, the system cannot work. So it is essential to store the data in the main memory to get it processed by the CPU. Now CPU will do the entire processing, whereas the input devices as well as the output devices are called as your dumb terminals. Dumb terminals only means only these will facilitate to input as well as output the data. But intermediately, the entire processing is being done by the central processing unit, and that's why it is called as your brain or processing unit. In another manner, the hardware, the computer system, the parts of the computers may be decomposed in two parts. One is your hardware part, another is a software part. So my computer is not only a bare machine. It is not only a bare machine, rather it consists of hardware as well as the software. Hardware is something, hard devices which you can touch, but software is some kind of a virtual concept. It is a collection of programs that help the hardware to work properly. So whenever you buy a machine from market, so it is not only a machine, it is not only a hardware part, rather some of the system software, some of the operating system already installed in that computer to make it work. And essentially the software which is meant to make the system functional is called as a system software. And the most common example of the system software is your operating system. Without operating system, your system cannot work. So this is the essential software to be installed in the computer to make it work. And the examples of the system software are Windows. Most of the time you are working in day-to-day life on Windows. Other operating systems are Ubuntu, or nowadays MacBook is also popular. So all these are the examples of your operating system. And operating system is an interface in between the machine as well as the user. It provides a platform to work further with the machine, to install further the other programs, so that the advanced systems, advanced websites may be developed. So operating system only works as a platform in between user as well as your machine. Now these are the examples of your input devices. Input devices again is the physical part of the computer system which allows data to be entered into a computer system. All these are the different categories of your input devices. Keyboard, essential input device is keyboard. By pressing on different kind of the buttons, the data is inputted in the computer, as in when you click on a key, its corresponding ASCII value is inputted in the system. Similarly, touch sensitive screen is there. By just touching the screen, the data is it senses the data from the point where you touch the screen. So automatically the data will be fitted in the system. Similarly, mouse, microphone, digital camera, digital video camera, joystick, scanner. All these are the examples of your input devices. Now, there are the output devices. Output devices are the devices which facilitate you to view the output or generate the output. There are the two types of the outputs. One is your soft copy, another is your hard copy. Soft copy is basically whenever virtually you are going to get your final output data, that will be called as your the output data in the soft copy form. For example, the monitor generates the output data in the form of your soft copy, in the form of a number of programs, and whereas the printers provide you the output data in the form of the hard copy. Whatever the data you view on the monitor, once you give the print command and printer is connected with the computer, you will be getting the hard copy of your final output data. Other examples are loudspeaker, projector, which will be producing your final output data. Memory we already have discussed. We do have two types of memory. One is your main memory, another is your secondary memory. And there are two types of main memory. One is your RAM, another is your ROM. RAM is a random access memory. It is a volatile memory. This is where information is stored temporarily while the computer is on, although this is lost when the computer is switched off. Means so far as the power is there, this memory will work for that much time. As the power goes, the contents will be lost. Read-only memory is only the read-only memory. No editing access permission is provided in this memory. Once the data is stored in the form of the ROM, or the users are only able to view the data and not being able to write the data in that memory. For example, if you talk about your operating system is nothing but a collection of a number of programs, and all the programs are being stored somewhere else in memory, but in the form of the ROM only, because no write permission is provided to the user due to the reason so that the users should not be able to hamper the data or damage the data. Once the user will try to make any kind of the editing in system programs, in the built-in programs of the operating system, the entire operating system will be halted, it will be corrupted. And that's why some of the essential system programs are being stored in the form of the read-only memory. Now these are the secondary memory. Secondary memory is basically where the permanently data is being stored. Hard disk is its main example. Other than that is floppy disk, CD-ROM, DVD-ROM, USB stick, pen drive, with the help of which the data can be ported, or external hard disk. The data can be ported from one device to another. Now we talk about your storage capacities. Just hold on. Yes. Now we talk about the storage capacity. If we talk about the data, data is being processed by the CPU, but the smallest unit of the data is bit. 0 or 1, these are called as your bits. Whenever the system processes the data, it processes only in terms of machine language. Machine language is the language of zeros and ones. Though from the user's understandability, so many other languages are available, like high-level languages and object-oriented programming languages, so that the users can better deal with those kind of the languages. These are the English-like languages. But so far as the system is concerned, it only understands the language of zeros and ones. So intermediately, in order to convert the high-level or object-oriented programming languages written by the user, or the program once is written by the user in those kind of the languages, ultimately is being translated in terms of zeros and ones internally with the help of the translators. You would have heard the word as compiler. We say like we have written a program in C++, we have to compile the program. What is the meaning of that compilation of the program? That means the user earlier has written a program in C++. That was good to write that program in the C high level language programming or object oriented programming language so as to enhance the understandability of the user. But if so far as the computer is concerned, it will not directly understand the language or the program written in object oriented programming language by the user. So it needs to be converted in terms of zeros and ones. So there are the compilers. Compiler is one of the category of translator. Whenever we are going to talk about object oriented programming or high level language programming, then translator is called as a compiler. Whenever we are going to talk about the assembly language programming, then the translator, the type of the translator is called as your assembler. Similarly, another type of translator is interpreter. Whenever you are going to talk about your Python programming language, that is your interpreted language. In that case, line by line, the program is scanned and that is translated in terms of zeros and ones, and side by side it is executed also. So translators again is a set of softwares in order to convert the high level or the assembly language program in terms of zeros and ones, and the language of zeros and ones is called as machine language, understood by the system. And now if we are going to talk about data, the smallest unit of machine language or the data is called as your 0 or 1, which is called as your 1 bit. At a time 1 bit. 0 will be called as 1 bit, 1 will be itself will be called as your 1 bit. Collection of 8 bits will be called as your 1 byte, and collection of 1024 bytes will be called as your 1 kilobyte, and collection of 1024 kilobytes will be called as your 1 megabyte, and 1024 megabytes will be considered as a 1 gigabyte, and collection of 1024 gigabytes will be termed as your terabyte. Now we come to the processor. Processor means by default we are going to talk about CPU, Central Processing Unit. The processor or Central Processing Unit is the brain of the computer. The performance of the processor is measured in terms of gigahertz. This is called as the unit of your speed. We send programs to the processor to get the computers to do something. Always the processors are being used to process the data inputted by the users and produce some kind of the useful information. What are the essential parts of the processor? These are control unit, arithmetical logical unit, and registers. What is the function of the control unit? It messages the fetching and executing of the programs held in RAM. It basically controls all the data which is being transmitted from one unit to another and makes sure that programs are processed in the correct order. Now, arithmetical logical unit, it facilitates all the arithmetical as well as the logical operations. What are those arithmetical operations? Addition, subtraction, multiplication, division, all these kind of the calculations are called as your arithmetic calculations. Whereas these different operations, and, or, not, if, or for loop, or these are called as your control loops, but these are called, and, or, not are called as your logical operations. So all these are facilitated by your arithmetical logic unit. Now we come to registers. Registers again is the storage locations on the processor chip to temporarily store instructions. So these are the again storage devices which are available in the CPU in order to store some kind of the instruction. In order to process some kind of the instruction, there is a need to use the registers which are already as a part of your processor. This is one of the part of your processor. Other parts are your control unit as well as arithmetical logical unit. Now we come to the very first chapter of your course contents, computer system architecture. Broadly, the title of your chapter is Digital Logic Circuits. Sorry. Under this digital logical circuits, in order to understand the behavior of digital logic circuits, we need to study Boolean algebra. Already you have studied the algebra in your maths in your 11th or 12th standard, but here specifically we talk about your Boolean algebra. Boolean stands for the two values, either true or false. True corresponds to the value 1 and the false corresponds to the value 0. So here what kind of the expressions we'll be dealing with? All the expressions, mathematical expressions, will be dealing with all the Boolean values. We'll be dealing with values either 0 or 1. All the inputs we'll be talking about will be 0 and 1, and all the outputs that will be produced will be in terms of zeros and ones. So here the algebraic equations consist of a number of variables. Those will be specifically your Boolean variables, means that those will be accepting the values as 0 or 1, and that ultimately will be generating
Ma'am, your
final
voice
value.
is not clear.
Voice is not clear? Yes? To others? Voice is clear or not?
Yes.
Clear. And voice
Ma'am,
is
it's
clear.
voice is clear.
That's clear. It's clear.
Okay. Okay, beta. Okay. Okay.
Yeah.
So we are talking about Boolean algebra. Boolean algebra deals with those algebraic equations in which,
But to me, it's not clear.
beta, just check your microphone or your speaker. Check at your end and then let me know. If others are being able to listen to, you should also be able to listen to. Let me know, is it clear? My voice is clear now? To others, is it clear?
Yes, ma'am.
I think it's network.
Yes, ma'am.
Yes,
Okay,
ma'am.
beta.
Yes, ma'am.
So Boolean algebra.
Yeah, ma'am, it's
Okay, beta. Okay.
yeah, it's network issue. I
Boolean
think.
algebra deals with the
Yeah,
binary
now
or
it's
Boolean.
clear.
Not
Yes,
yet.
ma'am.
Just check your connection. Check your connection, beta. Now the Boolean algebra is the algebra which deals with binary or Boolean variable and logical operations. Means all the variables will be consisting of the nature of the variable involved in Boolean algebra will be accepting only two values, 0 or 1, or true or false, and similarly it will be producing the same kind of the values. And side by side, we are not going to talk about here the arithmetical operations. Here we are going to talk about the logical operations. Boolean algebra is useful in analysis and synthesis of digital logic circuits. Now, why there is a need of Boolean algebra? Why we study the Boolean algebra? The only logic behind studying the Boolean algebra is to understand the behavior of the digital logic circuits. Digital logic circuits means integrated chips which are installed in the CPU, in the processor. So how these are to be designed, how its behavior is to be analyzed by the hardware engineers. Before, say they have to devise some of the digital logic circuit. So how would they be deciding that how many number of logic gates be used in that digital circuit? If they can enhance the number of logic gates, or they can reduce the number of logic gates, or they can reduce the complexity of digital logic circuit, or they can enhance the complexity of logic circuit unnecessarily. That will further enhance the time and cost of the hardware engineers. So in order to reduce the complexity of the digital logic circuits, there is a need to understand its behavior mathematically, logically, and that is the reason only the Boolean algebra comes up with the analysis part of the digital logic circuits. This is the only reason that we are going to study the Boolean algebra, how it works, the digital logic, how it works, that we study with the help of Boolean algebra. We'll see few examples in the subsequent slides, then you will get to know. And from a Boolean function, a logic diagram can be constructed using AND or inverter gates. Whenever we are going to talk about Boolean algebra, essentially we are going to talk about a number of logic gates. We are going to talk about truth table. Truth table is a table that characterizes the behavior of a Boolean expression that describes the output values for all the combinations of the input values called minterms and input variables. If n input variables are there, then there will be 2 raised to power n number of minterms. I will explain you all in the subsequent slides. First of all, let me share with you. Let me share with you your e-copy of your book in which the details of all logic circuits are given. Let me open e-copy of the book. This is your textbook, Computer System Architecture, specifically the 3rd edition by author M. Maurice Mano. And we already have started with first chapter. This is the first chapter, digital logic circuits, digital computers, logic gates, Boolean algebra, complement. These are the different subtopics. So directly I am coming to the first chapter. This is the first chapter, digital logic. Fine. Digital computer, introductory part of digital computers we already have done with. Now we come to specifically the logic gates, because logic gates are not mentioned in your PPT that I have sent you. So the details of the logic gate, the straightforward will do from the book only. The binary information is represented in digital computers by physical quantities called as signals, and electrical signals such as voltage exist throughout the computer in either one of the two forms. These two states represent a binary variable that can be equal to 1 or 0. For example, a particular digital computer may employ a signal of 3 volts to represent binary value as 1 and 0.5 volt to represent the binary value as 0. So how the binary value is represented in the system? With the help of which value of the electrical signal, electrical voltage, the value 0 is generated. So this is 0.5 voltage is supplied, then corresponding to it the binary value 0 is generated. And whereas if the electrical signal of 3 volts is produced, then it corresponds to the binary value as 1. And binary logic deals with binary variables and with other operations that assume a logical meaning. The manipulation of the binary information. Whenever we are going to talk about the binary values, definitely we are going to talk about its manipulation also its calculation also, and some of the operations are applied on the binary values. And for that purpose, here we come up with the logical circuits, the minimum block of the logical circuits, which are called as your gates. The manipulation of the binary information is done by the logical circuits called as gates. These are the smallest unit of the logic hardware unit of your logical circuits. So gates are blocks of hardware that produce signals of binary 1 or 0 when input logic requirements are satisfied. What are the kinds of the logic gates are there? What are their symbolic notation, graphical notation? So here we do have the list of all the logic gates given in your this first chapter. On left hand side, the name of the gates are given. What are those gates? AND, OR, inverter, buffer, NAND, NOR, exclusive OR, and exclusive NOR. All these are names. And how these work, the explanation is given on the right hand side. The graphical symbol corresponding to the AND gate is this. This is the graphical. All these are the hardware units installed within the logical chips imbibed in your computer system, in your CPU. And now the AND gate, what is the graphical symbol of the AND gate? Here 2 inputs are required, A and B. And this kind of the symbol is used, notation is used in order to represent the AND gate. 2 inputs are inputted and ultimately one output is being generated, which is called as X. So how do we write it? X will be equal to, and what is the logical operation that correspond to the AND operation? It is similar to the multiplication operator, though it will not work as a multiplication, it will work as a AND is called one of the logical operation, or again is called as a logical operation. Inverter again is called as a logical operation. So whenever we are going to talk about the Boolean algebra, we are going to talk about the algebraic equations with some of the variables having some of the Boolean values or binary values, and that deals with different logical operations. How these logical operations are performed, are fulfilled with the help of the logical gates. So whenever we are going to talk about the logical gates, means in terms of your Boolean expressions, in order to understand the behavior of that gates or any of the other logical circuits, we need to understand the behavior of it by writing down its Boolean expression. So in order to understand the behavior of AND gate, here the Boolean expression is given. What kind of the Boolean expression is there? X will be equal to A into B. So this star or dot both work as the logical operation in the context of your Boolean algebra. And side by side we do have truth table. So in this Boolean expression, we do have how many dependent variables? We do have two dependent variables, independent variables A and B, and X is the final value of the expression that is dependent on the values of A and B. So X is the final function value that is dependent variable, and two independent variables A and B, and correspondingly, in order to understand its behavior, we do have the truth table. Truth table is a table that consists of a number of min terms. Min terms means various kinds of the combinations, for all possible combinations. On left hand side we do have A and B, on right hand side we do have X. For A and B, with the help of the two values, because A and B are the Boolean variables, A can have either value 0 or 1, similarly B can have value as 0 or 1. So what are the possibilities for giving the input values? It can either be both are 0, 0, or it can be 0, 1, it can be 1, 0, it can be 1, 1. So all these are the possible combinations, input combinations. And based on the input combinations, what is the final value of function? If you manually place the value as 0, 0 in this expression of your AND gate, so 0 dot 0. How AND gate works? It says that when both values are true, like 1, 1, the result will be true, it will be 1. If both are false, result will be false. But if at least one is false, result will be false. So in first case, both are false, both are 0, 0, result will be 0. In the end, in the last, both are 1, 1, both are true, result will be true. In between, one is false, 0, 1, or 1, 0, so result will be false. So this is the truth table. Truth table is a collection of all the min terms. Collectively the value of input values as well as the output value is called as a one min term. So how many number of combinations? With the help of the two variables, it is how many variables are there? N number of variables. So how many number of min terms? 2 raised to power n. So 2 raised to power 2 means 4 number of combinations or 4 number of min terms will come out with the help of your two variables. If there are the three variables, how many number of min terms will be there in the table? 2 raised to power 3, 8 number of min terms. If there are 4 variables, how many number of min terms will be there in your table? It will be 2 raised to power 4, 16 number of min terms will be there. So at present, we do have only 2 variables. So there are only 4 min terms, and this is the truth table. So again, I am repeating, whenever we are going to talk about logic gates or any other integrated circuit, we talk about in terms of its logic diagram. This is called as a logic diagram, and this is called as a Boolean expression, and this is called as a truth table. So all these three will go in hand to hand whenever we are going to talk about your integrated circuits or logic gates. Now we come to OR gate or logic gate, or what is the graphical symbol? Its symbol is, this one is, we have to strictly go by its given standard symbols. We cannot violate its standard symbol, because in exams you will be asked, you will be given some of the Boolean expression. What kind of the questions will come up in your exam? You can go to the back exercise. You can start solving those questions, and you will see that you cannot violate the built-in standard graphical notations of all these logic gates. What kind of the questions will be given? That you will be given a Boolean expression, and you will have to draw its logic circuit diagram this kind of a diagram. This is the simplest diagram corresponding to the logic gates only, but further we'll be having the complex logic diagrams corresponding to complex integrated circuits. And then you will have to simplify Boolean expressions using two methods. We'll be studying two methods in this chapter for the simplification of the Boolean expressions. One will be your using Boolean identities, another will be your Carnot map. With the help of either of these two methods, you will have to simplify your Boolean expression, and ultimately you again will be asked to draw the logic circuit diagram. And then you will be asked to compare the number of the logic gates used in both cases. In the first case, whenever the diagram was complex, and in another case, when the diagram was in the simplified form. Now we come to the OR gate, how the OR gate works, what is the behavior of the OR gate. This is your algebraic function or the Boolean function in order to describe the behavior of the OR gate. This is your graphical symbol. And this is the truth table. This plus operator, addition operator, though it is not exactly addition, it stands for the logical OR operation. Though it is similar to the arithmetical addition operation, but its behavior is different in this case. Now again we talk about the truth table. As there are the two input variables, one output variable. There are 4 number of min terms. What are the possible combinations of the min terms? It is 0, 0, 0, 1, 1, 0, and 1, 1. Based on the input values, what kind of the output values you are getting? It says that when at least one value is true, result will be true, else result will be false. This OR operation says, like in this case, sorry. In first case, both values are zeros, means both values are false, result will be false. And in second case, when 0, 1 is there, if 1 is true, result will be true. At least 1 is true, result will be true. Similarly, last case, at least 1 or both are true, result will be true. Even manually, you can find out the similar kind of the values which is being depicted in the truth table. For example, the very first value is 0, 0. You place the corresponding values in the given Boolean expression. Place value of A as 0, place value of B as 0, 0 plus 0. Or says that 1 is false, result will be false. So 0, 0 will be equal to 0. Similarly, you place these corresponding values in this given Boolean expression, you will be getting the corresponding value in your truth table. Now we come to the inverter. This is the graphical notation of the inverter. It says that one's complement is taken of the inputted value. Here single variable is there, single variable is inputted, and complementation के लिए small circle is being used. And ultimately the derived output value is x. And the Boolean expression will be x will be equal to a dash. This dash stands for the one's complement of value a. A again is the independent variable, x is the dependent variable. And if we talk about the truth table, how many number of min terms will be there? It will be 2 raised to 2 raised to power 1. 1 is number of variable. Variable is 1, so 2 raised to power 1 will be equal to 2. 2 number of min terms. So what are the possible values, input values? Either 0 or 1. Now we come to the final output value to the right hand side. We talk about the value of x as the output value. If value of a is 0, then output will be 1's complement. 1's means it will invert its value. 0 will be replaced by 1 and 1 will be replaced by 0. If you don't understand any kind of the concept, you can interrupt me and you can ask me the question. Now we come to the buffer. Buffer is whatever the value, input value is inputted, the same value is being generated as the output value. And what will be its corresponding Boolean expression? It will be x will be equal to a. And what will be its truth value? Truth table value. Again, two min terms are there because single independent variable is there. So whatever the input value is there, same is being used, generated as your final output value. So 0 is the input value, again 0 is the output value. 1 is the input value, again 1 is the output value. Now we come to the NAND logical. Yes.
Excuse me, ma'am.
Yes, beta.
Ma'am, what is the use of buffer?
Actually, in some kind of the applications, sometimes we want the same value which is being inputted, we want it to be generated as such as the output value. In that case, the buffer is being used in those kind of the applications. You explore on net, okay, that which kind of such applications are there, and let me know as well.
Okay, ma'am. Thank you.
Okay, ma'am.
Now we come to the NAND operator, NAND logical gate. NAND is basically AND plus NOT. And what is the graphical symbol? It is similar to the AND, except here the small circle is being used. And here two input values are there, A and B, and one output value is being derived, that is X. And what is the Boolean expression for it? It will be X will be equal to AB dash. Means, first of all, the AND of A and B is being taken, and eventually its complement value is being taken. That will be termed as your NAND. And similarly, we do have the truth table. Again, two independent variables are there. So how many min terms will be there? It will be 2 raised to power 2. That means there will be 4 min terms. And correspondingly, there will be one output value. What are the corresponding combinations? Again, similar kind of the combinations as earlier we have used. 0, 0, 0, 1, 1, 0, and 1, 1. And what value is being derived? First of all, ending of 0, 0 will be taken. Ultimately, its 1's complement will be taken. This way, the value of x will be generated. So, what will be the ending of 0, 0? It will be 0. And its complement, if you go to its Boolean expression, its complement will be 1. And that is why here 1 is being written. Similarly, 0, 1. What is the end value of ending of 0, 1? It is 0. Again, its complement is being taken. So, it will become as 1. Similarly, 1, 0 का क्या हो गया? And हुआ, it will be 0. And its complemented value will become as 1. Similarly, in case of your 1, 1, well, ending of A1, 1 will be 1. Its complemented value will become as 0. Now we come to the NOR. NOR gate is again the OR plus NOT. As such, graphical notation of OR is being used, but jointly this small circle is being used of inverter. And ultimately it is termed as your NOR gate. And this is your Boolean expression for the NOR gate. A plus B ka complement. The complement of A plus B. And this is the corresponding truth table. Again, 4 min terms are there. One output value is there. How will it work? The OR of 0, 0 will be taken. OR of 0, 0 will be 0. And its ending, its complementing is being done. So complemented value of 0, 0 will be 1. Similarly, OR of 0, 1 will be 1 and its complemented value will be 0. Similarly, OR of 1, 0 will be 1, its complemented value will be 0. OR of 1, 1 will be 1, its complemented value will be 0. Now we come to the exclusive OR. This is the graphical notation of your exclusive OR, and this is your logical operation. Circle, and in between this plus sign is being imparted. So it will this will become as your symbol of your exclusive OR. It is termed as XOR as well. And what is the equation corresponding to this XOR operation? It works as this way. X will be equal to A dash B plus AB dash. Means by this formula, the value of X is being derived. And by this formula only, the value of all the x's are being derived in this truth table as well. So again, how many number of min terms? 4 min terms will be there due to the reason as there are 2 number of independent variables. So 0, 0, 0, 1, 1, 0, 1, 1. And how this value of x has come out? By placing all these values, input values in this Boolean expression, like placing the value of A as 0, 0 dash into 0. 0 dash will become as 1 into B, 1 into 0 will become as 0. Similarly, A B dash, placing the value of A as 0, 0 into 0 dash, it will become as 1. Let me see. 0 and 0 dash ka and ultimately ending will be 0. On this side 0 was there, on right side 0 was there, 0 plus 0 ultimately will become as 0, and so on. You can keep on placing all these input values in this expression and ultimately you will be getting the value of x. Now we come to exclusive NOR. Exclusive NOR again is the combination of your XOR plus inverter gate. Means again this complement, this complement or the small circle is being used, is joined with the XOR in order to work it as your NOR gate. Exclusive NOR. Whatever is the expression for XOR, over that only complement is being used in order to derive the value for exclusive NOR. You can compare these two expressions. Only in this case only complement operator is being used. And similarly, if we do compare these two truth tables, whatever the values under x variable are being coming out, the values under x are the simply the complement of all these values in the previous table. So 0 has become as 1, 1 is being replaced by 0, 1 is being replaced by 0, 0 is replaced by 1. So in this case, earlier wherever 0 0 both zeros were there, result was 0, 1 1 was there, result was 0, but here is the vice versa, where 0 0 result is 1, 1 1 result is 1, and so on. Now we come back to the our PPT specifically for the topic Boolean algebra. So we were talking about the Boolean algebra, and parallelly we were talking about truth table, Boolean expression, and logic diagram. What is a truth table? Truth table is a table that characterizes the behavior of a Boolean expression. Earlier, we have studied the truth table corresponding to the logic gates. Logic gates were the smallest unit of your logical circuits, the smallest hardware units. And there also we are talking about the truth table in order to study its behavior. There also we are talking about the Boolean expression in order to study the behavior of the logic gates. Now, but now we talk about the complex logic circuit diagrams, which are nothing but the combination of a number of logic gates. Here also we'll study the truth table, we'll study the Boolean function in order to study the behavior of your logic circuit diagram. This is called as the logic circuit diagram. So all these three terms will go in hand to hand, truth table, Boolean expression, and logic diagram. Like here we have one example. This is the Boolean function corresponding to, sometimes you will be given this Boolean function, you will be asked to derive its truth table, as well as you will be asked to draw its logic circuit diagram. So we are given this Boolean expression, you have to draw logic truth table. So first of all, you will have to determine its number of combinations, or you can call it as number of minterms. How will you be determining? You will be determining on the basis of the number of independent variables. How many number of independent variables here we have? We have the 3 number of independent variables, x, y, z, and 1 dependent variable. So with the help of the three variables, how many number of combinations will be there? It will be 2 raised to the 3. That means 8 number of minterms will be there. So on left hand side, you have to write down all the possible combinations. How will these be written? It will be 0, 0, 0, 0, 0, 1. It stands for value 1. So all these are the binary values. If you talk about in decimal values, you will be studying all the conversions from binary to decimal, vice versa, and binary to octal, and vice versa in your 3rd chapter. That is termed as your number system. There we'll study that what are the corresponding decimal values corresponding to these binary values. 000 is termed as 0 in decimal. 001 is termed as your 1 in decimal. 010 is termed as 2 in decimal. 011 is termed as 3 in decimal. 100 is termed as 4 in decimal. 101 is termed as 5 in decimal. 110 is termed as 6, and 111 is termed as 7 in decimal. Now, how we have found all these values of x by f? By placing all these values of input values in the expression. Once you place all these values, and in between we do have the logical operations. What are those logical operations? This plus stands for your or operation, and this dash stands for your complement, one's complement. In between, dot stands for your and operation. So by placing all these values, you are being able to derive all these values of your function f. So we take one example. We take very first value 000. All of you take out your notebook and pen, and by placing the value as 000, tell me what value of f is coming out. Let me know. Just take out your pens and notebook. Yes, please.
Ma'am, value is 0.
Yes. If you place the value of x as 0, plus y dash will become 0 ka y dash, it will become as 1 into 0. 1 into 0 will become as 0, and 0 plus 0 will become as 0. Similarly, we can take for the derive the value for the next min term 001. So this is the way how we derive the final value of the expression based on the values of your input variables. Now, based on this expression, you have to derive the logic circuit diagram. This is the logic circuit diagram. How it is being drawn. That in between you are having how many variables are there. First of all, you have to decide number of variables. You do have 3 variables. Straightforward, you write down x, y, and z, and there is one inverter operator over y. So you have to place the inverter operator logic gate. Yeah, till this point we do like that, and afterwards you have to come to the small sub expressions. Now small sub expression is y dash z. In between there is the and operator. So that means y dash, y is being inputted in inverter gate. Y dash is coming out in between, and side by side z is there. In between z and y dash, and operator and gate is being utilized. Due to the reason as here is the dot operator. What will come out? Y dash z will come out. Now, what is there? There is the OR gate. In between x is coming on one side, and y dash z is coming from this small circuit, y dash z, and both are being inputted as the input values in NOR gate. NOR, why? Because here the plus operator is there. Plus is logical. This is the logical operation, OR gate. So here logical OR is being used, and ultimately f is being derived. So this is the way to draw a logic circuit diagram corresponding to a given Boolean expression. Now we come to the next topic, that is your basic identities of your Boolean algebra. First of all, I would like to come to the back exercise of the book. We come to the back exercise of first chapter. Yes. Today we will be covering up the simplification of the Boolean expressions using Boolean identities, and based on that you have to solve first 7 questions from back exercise. First 7 questions, and we will be discussing all these questions in the next class. You will be solving and you will be submitting me in the form of the assignment as well. Okay, so what is the first question? Determine by means of a truth table the validity of the De Morgan's theorem for 3 variables. Here the given Boolean expression is there, and this Boolean expression signifies the De Morgan's law. We'll study the De Morgan's law in the subsequent PPT, in the PPT subsequent slide, and you have to De Morgan's law, and you have to basically show the validity of the De Morgan's law. You have to, with the help of a truth table, that left hand side is equal to the right hand side. You have to show. Now next is list the truth table of a 3 variable exclusive OR. Means you have to derive its truth table. Though already you have seen the truth table for the 2 variable for exclusive OR, that is the solved part of your chapter. Now in a similar manner you have to draw the truth table for the 3 variable of exclusive OR gate. Next question is simplify the following Boolean expressions using Boolean algebra. We are going to study the Boolean identities that will be helping you in order to simplify the given Boolean expressions. Using those Boolean identities, you have to solve this question. This question as well as the subsequent question, simplify the following expressions using Boolean algebra. Then you have to solve question number 5. We'll be studying De Morgan's theorem. Using the De Morgan's theorem, again you have to solve it. Then given the Boolean expression, derive an algebraic expression for the complement. Means value of f is given, and you have to find out its complement, f dash. In order to find out f dash, you have to have the complement on both sides. Then you will have to apply the De Morgan's law. Then you will have to open this expression by using De Morgan's law, and ultimately you will be able to finding out the value of f dash. Once you find out value of f dash, you are having the value of f already in your hand. Ultimately you have to find out f into f dash. Into here stands for AND operation. That you have to show that will be equal to 0. Afterwards you will have to find out f plus f dash, and you will have to show that it will be equal to 1. And then question number 7, given the Boolean expression, list the truth table of the function. Means here Boolean expression is given and you have to draw its truth table. How will you be drawing its truth table? You will be observing the number of variables. How many variables are there? X, Y, Z. I can see 3 variables. With the help of the 3 variables, how many minterms? 2 raised to the power 3. 8 minterms will be there on as the input values. Then f will work as your final output value. How will you be deriving the value of f? By you will go on placing the corresponding values of x, y, z in order to derive the value of f. This way you will be able to obtain the truth table of f. Now we switch back to the PPT. So this is your homework basically. This is to inform you that officially I am on leave this week. So our next class will be conducted on next Tuesday. Is that okay?
Okay, ma'am.
Yes, ma'am.
So by that you have to solve these questions from back exercise. Now we come to basic identities of Boolean algebra. All these identities will be helping you to simplify the given Boolean expressions. You can view the 2 parts, left hand side as well as the right hand side. All the Boolean identities on the left hand side correspond to your logical OR operation. Everywhere you can view plus plus plus, it stands for the logical OR operation. On right hand side you can view the logical AND operation. These are the standard built-in identities. These can be utilized as such. What the first identity says, it says that x plus 0 is equal to x. It says that if 0 is being, OR operation is applied with variable, and if another variable is 0, always it will give you the value of the variable itself. You can prove it otherwise. One time you can take the value of x as 0, another time you can take the value of x as 1. Because variable can take only one of the 2 values, either 0 or 1. In both the cases, every time you will be getting the value x as such. Means x ki value if you one time take as 0, 0 plus 0 will be equal to 0. So it will be equal to x. Another time if you take the value of x as 1, then 1 plus 0 will be equal to 1. So that means again it is x. So it proves that x plus 0 is equal to x. Now x plus 1 is equal to 1. It says that whenever we are going to talk about the logical OR operation, in that case, if one of the operand, one of the variable is 1, so irrespective of the value of another variable, always it will produce you the value as 1. How? Key, again two possibilities are there. Value of x can either be 0 or it can be 1. In case its value is 0, in that case 0 plus 1 will be 1. 1 is a true, result will be true. And in case value of x is 1, in that case also 1 plus 1 will be 1. Means both are, if at least 1 is true in case of your logical OR, result will be true. So hence it proves. Now next identity, what it says that x plus x will be equal to x. We are not talking in terms of the arithmetical operation. If you would have talked in terms of arithmetical operation, it would have become as 2x. But rather we are going to talk about in terms of the logical OR. So as per the logical OR operation, if at least 1 is true, result will be true. 1 is false, result will be false. X key value in one case we take as 0. 0 plus 0 will be 0. Hence it proves. Another case may be 1, x key value 1. In that case 1 plus 1 will be 1. So hence it proves. Now we come to the next Boolean identity, that x plus x dash will always be 1. How? That means 1 always will be true and hence result will be true. True means 1. Means if we take value of x as 0, then x dash will be true. It will be 1. Hence the result will be true. That means it will be 1. In case we take value of x as 1, already true, then x dash will be false. But already one variable is true. Hence the result will be true. That means it will be 1. Next identity is a commutative law. It says that x plus y will be equal to y plus x. So the order of the elements does not have any impact on its value. It will retain its value as such in the final on the right hand side as well. So we can change the order. So if x plus y is done or y plus x is being done, so ultimately it will give you the same value. And the commutative law can be applied on 3 variables as well. It says that x plus y plus z means first of all y plus z is being done, and then ultimately it is being operated with x variable. Ultimately it will give you the same value in case x plus y is being done, and ultimately it is being added, not added, rather logical OR operation is applied with the z. It will give you the same value. Now this is called next identity. Identity number 13 is called as your distributive law. It says that if x into y plus z will be equal to, means x is being not multiplied, rather logical AND operation is applied over x and y as well as x and z. It is called as a distributive law. Basically this law number 13 and law number 14, basic identity, both are called, these are the distributive laws. They are the different modes. One mode is this kind of the mode, says that this kind of the expression on left hand side is there, so it will be equivalent to the right hand side, equivalent to the expression written on the right hand side. Now we come to the another distributive law. It is extremely very important. Point number 14. This kind of the law is being used generally in the simplification of the Boolean expression. You will find in the back exercise, as and when you get this kind of the expression on left hand side, x plus y z, it can be rewritten as the right hand side, and that further will help you to simplify the Boolean function. Simplify the Boolean function means it will help you to reduce the number of logic gates in the logic circuit diagram eventually. So x plus y z can be rewritten. How it can be rewritten? In what manner? X is being used with y. Similarly, the same x is being used with z. So it can be rewritten equivalent to the right hand side. And again, I am repeating that this is the very important distributive law that generally is being used in the simplification of a Boolean expression. And some of the questions are there in your back exercise, and you straightforward take the help from these Boolean identities. Now we come to the distributive law. No, not distributive, rather De Morgan's law. What the De Morgan's law says, it's point number 15 and point number 16. Both are the part of your De Morgan's law. It says that whenever the complement of the two variables is being taken in between when logical OR operation is applied, so it can be rewritten as x dash into y dash. That means x plus y dash can be rewritten as x dash into y dash. This is one of the way of writing De Morgan's law. Again, it is being used in the simplification of your Boolean expression. These two laws of De Morgan's theorem is extremely very important. Similarly, what is another mode of De Morgan's law? Xy dash is equivalent to x dash plus y dash. Means in between this AND operator is replaced by the OR operator, and this complement comes out individually to all the variables separately. It says like that. Similarly, in case of point number 15, this plus or the OR operator is being replaced by your AND operator, and this complement is applied individually to all the variables. So it says the De Morgan's law. And a few more are left to the right hand side in the beginning, and prior to that we come to the 17th law. Says that complement of a complemented value, again it generates the same variable as such. Means once we take the complement and we take again the complement of the complemented value, it will generate the same value x. Now we come to the right hand side, to the topmost right hand side. It says that again some of the few basic identities corresponding to the AND operator are there. It says that x into 0 is equal to 0. Into stands here for the AND operator. It says that whenever a variable is being ANDed with any value 0, it always will generate the value as false. 0 stands for the false. Similarly, x into 1 means if one of the operand is 1, then the result of the Boolean expression entirely will be dependent on another operand x. If value of x is 0, it will give you the value as 0. Value of x is 1, then it will give you the value as 1. That means if one of the operand is 1, so the result will be dependent on the very first variable, by very first operand. Similarly, x into x will always be equal to x, and x into x dash will be equal to 0. Means in order to understand all these concepts, you can place the value of x at one time 0, and at another time you can place the value of x as 1, and manually you can derive the value, and ultimately will come up all the values placed on right hand side. Now x into y will be equal to y into x. This is called as your distributive commutative law. Similarly, x into y into z can be rewritten as x into y into z. Again, it is called as a commutative law, and these next two laws we already have studied. Now why we are studying all these? I already have told you that our simply significance of studying the Boolean algebra and significance of studying all these basic identities is to simplify all the Boolean function, and henceforth simplify the logic circuit diagram, and henceforth simplify the logic circuit chips, integrated chips installed by the engineers in the CPU. This is the significance of studying all these Boolean identities and of the Boolean algebra. So usefulness of this table is simplification of Boolean function. Why there is a need to simplify? Because once we are going to simplify Boolean expression, correspondingly we are going to simplify its logic circuit diagram. Simplification means we are going to reduce the number of logic gates employed in order to frame that logic circuit integrated chip, and less the number of logic gates will lead to its less cost. Means if the two logics, we are going to talk about the two logic circuit diagram, and one logic gate is unnecessarily using more number of gates, though both are giving the same functionality, but we do have another form of the logic circuit diagram which is simplified one. Again, it is giving the same functionality. Then why there is a need to unnecessarily using more number of logic gates? That ultimately will enhance the complexity as well as maintenance cost as well as its building cost. So usefulness of this table is simplification of the Boolean expression, derivation of equivalent Boolean expression. Means once the Boolean expressions are simplified, the simplified version will also work as the earlier one. It will give the same functionality. And to obtain logic diagrams utilizing different logic gates. Logic gates will also be reduced. We take few examples now how to simplify the Boolean expressions using the logic gates. These are all entities, Boolean identities we already have studied. Now I directly will come to few of the examples. This is very first example, A part, A plus AB. Left hand side, if needs to be simplified using the Boolean identities, how will it be simplified? A will be taken common. In between, we will be left with 1 plus B. And by using the Boolean identity, what the Boolean identity says, 1 plus B is always equal to 1. If you go by it, x plus 1 is always equal to 1. We have applied this Boolean identity. And we have to mention the reason behind that, why we are going to simplify, how we are going to simplify. So within parentheses, towards its right hand side, we have to mention the reason, since x plus 1 is always equal to 1. Similarly, 1 plus 1, 1 plus b will be equal to 1. Now a dot 1 will become as equal to a. A dot 1 means x dot 1. Again, we have utilized one more Boolean identity. X into 1 is equal to x. So here we have used two Boolean identities. Second time we have used this Boolean identity. So if we do compare these two expressions, a plus ab, or another time we have generated a, means a plus ab is equal to 0 or a is equal to 0. So both are working in a similar fashion. Both are doing the same function, functionality, producing the same functionality. But it is a simplified version, or right hand side and left hand side is the complex version. If it similarly, we take another example, a into a plus b. How to reduce this Boolean expression using those Boolean identities we have studied earlier. Just open the bracket, a into a plus a into b. A into a, again we are going to apply one more Boolean identity, that a into a will be equal to a. Like x into x is equal to x. We have studied this. We have applied it. After applying it, we got the result as a into a will be a plus ab. A will be taken common. 1 plus b. 1 plus b will be equal to 1. A into 1 will be equal to a. Ultimately, we got the result. We got the simplified version as a. So this way, but do remember this thing, as and when we are going to simplify the Boolean expression on right hand side within parentheses, we have to keep on mentioning the reason that we have used which of the Boolean identity in order to reduce a given example, that we have to mention side by side. Now though earlier we have studied De Morgan's theorem, but now we study for more number of variables. Here for two variables, how it works, there are the two versions of De Morgan's theorem, A part and B part. It says that a plus b dash will be equal to a dash into b dash. Another version says that a b dash will be equal to a dash plus b dash. Means in first a part, plus or this logical or will be replaced by and this complement will come inside individually to all the variables. So it will become as a dash into b dash. And in b part, ab dash will be equal to a dash plus b dash. Means this and is replaced by or, and this dash, which stands for the complement operation, comes over to each and every variable. So it will become as a dash plus b dash. Now generalize De Morgan's theorem. It basically applies for the n number of variables. It says that similar kind of the versions are there, a and b. A plus b plus z means n number of variables are there over, and complement of all these variables, whereas in between the or operator is there, is taken, and on right hand side it will be equivalent to this expression a dash into b dash and dash dash into z dash. Similarly, means all or operators are replaced by and operators. Similarly, this complement of anding of all the variables is being taken, that will be equivalent to the ORing of all the complemented variables separately. A dash plus B dash. So now these two De Morgan's theorem further will be applied in order to simplify your Boolean expression. Complement of functions. What we mean by the complement of function? Whenever the 0 is replaced by, whenever we say that x complement means 0 is replaced by 1 and 1 is replaced by 0. That will be called as the ones complement or complement of x. Similarly, complement of your entire expression can be taken as earlier taken in case of your De Morgan's law. In A part, we have taken the complement of the entire expression. In B also, we have taken the complement of entire expression, and ultimately it is equivalent to this expression by the De Morgan's law. The same thing is repeated here, nothing else. Again, we are going to talk about the De Morgan's law only in this slide as well. That and will be replaced by or will be replaced by and individually the complement will come up to each and every variable. That's it. Now, basic identities of Boolean algebra that we already have done. Yes, this is one more example. That here we are given a Boolean expression f is equal to x plus y dash z. You have to find out, draw its truth table, means you have to identify number of variables x, y, z. You have to write down its min terms. 3 variables are there, so 8 number of combinations will be there. One by one, you have to keep on placing its input values in the function. Eventually, you will be deriving the value of y, and you will be writing down in the form of the truth table all possible combinations of input variables in truth table, and ultimately you have to draw its logic circuit diagram. Again, the same way I already have told you, the x, y, z, those many number of variables are there. One inverter gate is being used in front of your y, and then AND gate. You have to come to the sub expressions. First of all, you have to draw the logic circuit diagram for sub expression, and ultimately as a whole you have to combine the entire logic circuit diagram with some main operator, like here in this case OR operator. Same thing is being repeated. Use Boolean algebra to simplify Boolean functions to reduce simpler circuits. Again, one more example is there, that if we do have one of the Boolean expression as f is equal to x plus x dash y x, how we are going to apply the Boolean expressions? See, x plus x dash y, इसे हमें simplify करना है. What has to be done? X plus x dash y. Here the distributive law is applied. I told you the distributive law for number 14. It is extremely very important. Which distributive law? X plus x dash y. So this x will be combined with x plus x dash. This x again will be combined with y. I go back to the distributive law just to recall. Let me show you that this was the distributive law. That was very, very important. This point number 14. X plus yz will be equal to x plus y into x plus z. So this of the distributive law we have applied on that expression. I go back to the same expression that we were talking about. So this is the distributive law that we have applied, and you have to mention the reason on right hand side within the parenthesis. X plus x dash into x plus y. Now x plus x dash will always be equal to 1. So ultimately 1 into x plus y. Ultimately you are left with x plus y. So see, you have got the simplified version of your Boolean expression, and the way you are going to get the simplified version, automatically the number of logic gates automatically are reduced in the simplified version. Again, the different versions of these Boolean expressions are there, and they are the different kinds of logic gates for the same Boolean expression. One for the simplified version, another for another simplified version, and all are producing the same kind of the functionality. Initially we begin with f. This is one of the example, and we say that how many number of gates are being used in one part. 1, 3 AND gate, 2 inverter 5, 1 OR 6. If you come to the second version of reduced version for 2, 3, 4, 5, 3 and 5, 6, 7. In 2 rather we are going to use 7 logic gates. If you come to the third version, only 2, 3, 4 gates are being used. So this way if we simplify more the Boolean expression, so the more number of gates will be reduced, and the same functionality can be achieved with the less number of gates. So initially we are having f is equal to abc plus abc dash plus a dash c, and we have reduced. We have taken common ab in between c plus c dash plus a dash c. C plus c dash is equivalent to 1. This way ultimately we have come up with ab plus a dash c. So the more we reduce the expression, more we reduce number of logic gates in the used in logic circuit diagram. So again the same thing, we are going to talk about Boolean function, vice versa we are going to talk about its truth table, and vice versa we are going to talk about Boolean logic circuit diagram. This is first method of simplification of your Boolean expression. Another method is the K-map. Means next topic will be studying K-map to simplify your Boolean expression. Now based on your first chapter, your Boolean expression, Boolean algebra and using Boolean identities, you have to solve the first seven questions of your back exercise, and you have to submit me in the form of the assignment on the same mail ID through which I sent you the invite link. And if you do have any